Hello, I'm Don MacHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 25 for the week of June 24th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, June 24th, the moon is a crescent in the evening sky. Each successive night it moves about 15 degrees eastward in reference to the stars, sets about 45 to 60 minutes later, and gets brighter. The moon reaches first quarter on June 28th, and by the end of our week, which occurs on Tuesday, June 30th, the moon will be in our southern sky, approaching the constellation Scorpius. The moon is always interesting in any telescope. As a terminator, the line separating light from dark slowly moves across the face of the moon in our evening sky. It not only reveals new areas every hour, but the shadows in the lit area shorten, so the moon has a never-ending changing appearance. Those of you interested in the moon, planets, comets, or anything in the solar system might want to check out the Association of Lunar and Planetary Observers. It's also known as ALPO. Yes, ALPO. This organization, founded in 1947, has sections devoted to the sun, moon, planets, comets, asteroids, meteors, and more. It costs little to join, but as a member, you receive each month links to a downloadable booklet of lunar observations, drawings, and photos, comet news, meteor news, and a solar report. A journal each quarter has additional information about the solar system. It also has a free item. You do not need to join for this, a podcast called Observer's Notebook, available on the internet from SoundCloud. It has interviews with various amateur astronomers about the solar system. Good stuff. Both Jupiter and Saturn are a few weeks away from opposition. That is when we are between them and the sun, and they are closest to us. At opposition, a planet rises at sunset. It's up all night long, and it's highest in the sky at midnight. That occurs at opposition, but in the weeks before and after, the planet is still well placed. Presently, first Jupiter, then Saturn rise about an hour or two after sunset. So once your sky darkens and you get settled and observe a few objects, such as the moon and maybe a few deep sky objects, these planets will be rising in your southeastern sky. Presently, Jupiter and Saturn are 6 degrees apart. This will increase slightly to 8.2 degrees by mid-August. Then, by early September, they begin to close in on each other until they are within a fraction of a degree of each other on December 21st. Mars rises around midnight, and it's already brighter than Saturn. Mars is at minus 0.45 magnitude, while Saturn is at plus 0.25, a difference of 7/10 of a magnitude. Jupiter still reigns in this area at minus 2.7. On September 27th, Jupiter will have dimmed some, and Mars will have brightened greatly, and Mars will overtake Jupiter in brightness. While you're looking at Mars, notice its color. It's referred to as a red planet, but to me anyway, it appears reddest when it is dim, maybe more like orange. As it brightens, it looks more yellow than red. Will you be able to see the International Space Station this week? If you live north of 50 degrees north, then it will not be visible this week. Canada, England, Norway, Finland, not at this time. Between about 25 degrees and 50 degrees north, you'll see it in your morning sky all week for some of you, and the second half of the week for others. Italy, Spain, Japan, get up early and see this thing. Further south, down to about 15 degrees north, it will be in your morning sky during the second half of the week. Mexico City, Egypt, get out there soon. From about 15 degrees north to about 25 degrees south, you will not see it at all. Colombia, Brazil, no, not this week. South of 25 degrees south, it's in your evening sky. And most of you, Australia, Argentina, South Africa, will have it in your evening sky for only the first few nights of the week, then nothing. New Zealand, further south, will have it in their evening sky all week long. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on International Space Station. There is a space probe that orbits the sun about 1 million miles closer to the sun than we are, and monitors 24/7 the sun in solar vicinity, sending images to the Earth on a regular basis. The name of the satellite is the Solar and Heliospheric Observatory, better known as SOHO, capital letters SOHO. It was launched in December 1995 and began operations in May 1996. It's operated by both the European Space Agency, known as the ESA, and NASA. You can see images from this satellite on your computer and on your smartphone. The website SOHO, www.nascom.nasa.gov, or search SOHO Satellite Live, and it will take you to the same page. On that page, you'll see where it says The Sun Now. The Sun Now. Click on that and find current images of the sun and solar activity. So once again, go to search SOHO Satellite Live and click on that page, which is soho.www.nascom.nasa.gov. And on that page, you'll see where it says The Sun Now. Now you click on that and you can find current images of the sun in solar vicinity. 6 of those 8 images are of the sun in different wavelengths. These are neat, and you can even make GIF movies showing the sun over the last few days. Also available are the LASCO images. LASCO, LASCO, stands for Large Angle Spectrometer Coronagraph. It blocks out the sun so that the objects near and behind the sun can be observed. The C2 camera, the red one, shows a close-up of the solar vicinity. Its field of view is 1.5 degrees across. Now, for reference, the sun is 0.5 degrees across. The one I find more interesting is the C3 images, the blue ones. They show the sky within 7.5 degrees of the sun, a total width of 15 degrees from one side of the image to the other. New images are added every 15 to 60 minutes. Look carefully at the C3 image. The round circle in the center is where the sun is located. The blue solid circle surrounding it is a round disk attached to an arm extended from the spacecraft, and it covers the sun. What I find most amazing, however, is those white spots in the image. Those are stars, far away and behind the sun. The same stars you would see in your daytime sky if the sun wasn't in the way. When the sun passes by a star cluster, for instance, you can see it go through the field of view in about 10 to 15 days from left to right. Planets show up here too. So do asteroids and comets. In fact, beginning June 16th and lasting for a few days, Comet 2020 F3 NEOWISE will be in the field of view. You and I cannot see it in our sky because it's too close to the sun. But SOHO can, and so can anyone who reaches the SOHO website. This is exciting, and it gives us a chance to see the comet before it emerges into our northern morning sky next week. We can see how it's holding up, or if it's fizzling out. New comets are sometimes discovered on these images. For the past 25 years, before the term citizen scientist was even invented, amateur astronomers, astronomy enthusiasts, and comet enthusiasts have examined the C3 images and sometimes the C2 images for telltale signs of a new comet entering the field. On the average, 2 or 3 times a week, a new comet is discovered. These comets are not named after the discoverer. They are named SOHO followed by a number. That is because the discoverer is not using his or her own equipment to find the comet, but they're using the SOHO cameras, which they do not own. The comet naming rules say that a comet then is named after the observatory, the program, or the instrument used to find the comet. Last week, the 4,000th comet was discovered using the SOHO cameras, so that was Comet SOHO 4000. Most of these comets are members of a group of comets known as the Kreutz sun grazers, and that's spelled Kreutz. This group is named after German astronomer Heinrich Kreutz, who discovered the group. These comets go out to 170 astronomical units from us, 4 or 5 times the distance to Neptune, then turn around and come back with a period of several hundred years if they survive. Most do not survive this very close passage to the sun. You see, the SOHO comets, almost all of which can be seen only in the SOHO images and are too faint to be seen from the Earth, have a nucleus only a few meters across, and nearly all of them disintegrate as they near the sun. Therefore, they are visible for only a few hours. You too can find comets in the SOHO images. You need internet, time, and experience. Several individuals have each discovered more than 100 comets over the last years, and there is another website that has all the communications among those who examine these images for new comets, along with instructions on how to find and report the comets. That website is sungrazer.navy.mil. That is once again sungrazer.navy.mil. It will give you everything you need to get started in discovering SOHO comets. I have spent some time looking this over, and I can attest that those who are searching for and finding comets are sharp-eyed and very good at finding those tiny, faint, slow-moving dots moving into the frame, some eventually developing a tail and some not. It is a competitive sport. You will occasionally find someone making a claim of a new comet, only to retract it when more images fail to show it. A comet that I discovered in 1986, known as 96P MACHHOLZ, is a frequent flyer to the SOHO cameras, and when it was first seen by SOHO in October 1996, it was used to help calibrate the position of the SOHO satellite. 96P returned in 2002, 2007, 2012, and 2017, and will be back again in early 2023. In 2012, two small fragments were seen leading it through the field, very faint, but it was picked up by the sharp-eyed observers of the images. And in 2017, 3 fragments were seen leading the comet. This comet, 96P, is also related to 2 other comet groups that frequent the SOHO cameras, the Marsden group and the Croc group. The comet appears to be related to asteroid 2003 EH1, responsible for the quad meteor shower every January, and the comet and its derivatives is responsible for 8 meteor showers, half of them being minor showers. The whole thing is called the MACHHOLZ complex. Look it up, MACHHOLZ complex, and this system was pieced together in part by what has been found in the SOHO images. The SOHO satellite has one more instrument that is of interest to comet enthusiasts. That is the Solar Wind Anisotropes. The abbreviation is SWAN, spelled capital letters SWAN. It scans most of the sky, not just near the sun. The images are released every 2 or 3 days. It was a SWAN instrument which found our recent comet SWAN in April. The person who discovered it was Michael Matazzel. He found most of the dozen or so SWAN comets through the years. Let's hear it for the SOHO spacecraft and the amazing things it has photographed. With 4,000 comets found by those on the ground who scan images like a well-trained staff. Now for our comet report. Comet Pan-STARRS 2017 T2, magnitude 9, is in our evening northern sky, slowly heading south. It's plotted on Podcast 25 Map 1 for the next 2 weeks. Podcast 22, Comet Positions, has coordinates for the comet for the next month. The same document, Podcast 22, Comet Positions, has coordinates for these next 2 comets. Comet 2020 F3 NEOWISE is in the SOHO images as our week begins. Now everyone can analyze it. How's it doing? It is moving north and will be in our morning sky for a few days, beginning visibility about July 3rd or 4th. After less than a week, it clearly becomes better visible in our northern evening sky, where it will remain for the next couple of months. Comet 2019 U6 Lemmon is low in the west as the sky darkens. I picked it up from Arizona on the evening of June 21st with an 18-inch reflector just above my western horizon. With each passing evening, it becomes easier to see as it gets higher above the horizon. This week, it becomes visible to northern hemisphere observers. It's about magnitude 6 and sports a fine tail. This comet was discovered from Mount Lemmon, part of the Catalina Sky Survey. Since June 5th, a lightning-caused fire has been burning northeast of Tucson, Arizona, in the Catalina mountain area. It's known as the Bighorn Fire. Mount Lemmon and the observatory were threatened by the fire but have survived. As of this week, 51,000 acres have burned. It's only 20% contained. 900 personnel are working on this fire. This week, we'll visit the constellation Lyra, which is a lyre or harp, although many people see it as a parallelogram with a bright star added to the top. In either case, the constellation Lyra is labeled on Podcast 25, Map 1. Once you have found it using that map, go to the more detailed map of Lyra, which is Podcast 25, Map 2. Lyra is in the northern summer Milky Way and therefore has numerous variable stars in it, and a few double stars, one bright planetary nebula and one globular cluster. So get to know this constellation, a major player on the block. Vega, the brightest star in this constellation, forms what is known as the summer triangle with two other stars in our northern sky. These two other stars are the star Deneb in Cygnus and Altair in Aquila. These three stars are marked on Podcast 25, Map 1. The summer triangle is not a true constellation, but it is an often referred to grouping in the summer sky. Podcast 25, Map 2 is a detailed map of Lyra with items identified that we will see in both binoculars and a telescope. Let's begin with the star Vega. 25 light-years away, the fifth brightest star in the sky, number 2 in the northern hemisphere behind Arcturus. If you saw the movie Contact, this is where Jodie Foster went. It's an extremely hot star, and that gives it its blue color. Look at it in both binoculars and a telescope. We show this at the public star parties, and it is a favorite for its brightness and its color. As an aside, when I was young, my father, who was in the U.S. Navy, was assigned to a ship called the USS Vega. Later, he was on the USS Sirius. Northeast of Vega is a double star, and each of those two stars is also a double star, so it's known as the double-double. In binoculars, it will appear as a wide double, easy to split, being 3.5 arc minutes apart in magnitude 5. With the unaided eye, you might even be able to split it. Through a telescope, cranked up to 100 magnification at least 4-inch aperture, and with steady skies, each of these two stars splits again at 2.6 and 2.3 arc seconds. One odd thing about this group is that one set of double stars is oriented in one direction, and the other set is oriented in a direction nearly perpendicular to the first. At public star parties, we put a large aperture, high magnification telescope on this object so that the public can see all 4 stars easily. Next, we have Zeta Lyra, a double star in which the components are 44 arc seconds apart and magnitudes 4.5 and 5.9. Through binoculars, this can be split, but it's not easy. A telescope, though, can easily split it. Our third and last double star in Lyra for this week is Beta Lyra, with a separation of 46 arc seconds, but the stars are magnitude 3.4 and 8.6, a difference of 100 in brightness. Binoculars cannot split this, but a telescope can. But with your binoculars, sweep the area and you'll see lots and lots of stars. M57 is our next object. It is a planetary nebula, and this one is known as the Ring Nebula, looking like a donut in the sky. Well, a very small donut, At magnitude 8.8 and 1.5 arc minutes in size, slightly oval in shape. It was caused when a shell of ionized gas is emitted by the star in the center. It's 2,300 light years away and is young, about 7,000 years old. It's very difficult in binoculars, but very nice in a telescope. I first saw the Ring Nebula in the summer of 1966 through my 2-inch refractor telescope. It took me 3 nights of searching before I noticed it. That is because I was looking for something larger, not a small, out-of-focus star like this object. When I finally recognized it, it was a memorable moment in my early stargazing life. Our final object is a globular cluster M56. It's also shown on Podcast 25, Map 2. At magnitude 8.3, technically it's visible in binoculars, but it's better seen in a telescope. It's 33,000 light years away, contains hundreds of thousands of stars. In a larger telescope, many of the stars can be resolved. Last week I discussed how you can do the Messier Marathon any time of the year and set the scene if you want to do it this week. I did the Messier Marathon from my home in Arizona last week, June 17th to 18th, and saw 95 of the 110 Messier objects. At this time of year, 95 is the maximum number of objects visible. I picked up the first 83 objects in the first 94 minutes, then went to bed and got up again around 2 a.m. for the remaining objects and some comet hunting. For this Messier Marathon, I used my binocular chair and 25 by 100 binoculars. You have been listening to Looking Up with Don, podcast episode number 25 for June 24th, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. I'm still sounding a bit hoarse this week. I hope over the next few weeks it will begin to clear up. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky. We'll begin earthbound observations of comet NEOWISE, and we'll learn another constellation. Thank you for listening. See the sky this week. I'll see you next week.